Today, we are diving into one of the coolest ideas in electrochemistry, and that is the Faraday's law of electrolysis. I'll be breaking it down into the simplest and easiest way to understand. So please stay with me. First of all, let me remind you what is electrolysis. Electrolysis, simply put, is a passage of what? Electricity through a substance, either in its molten state or aqueous solution. And then it is being decomposed by it. What does that mean? When you pass electricity through any of these substances, molten or aqueous, it will split it. That's what it means. Now, Faraday's work in 1830s is based on the relationship between the quantity of electricity passed and the amount of substance deposited during electrolysis. That is all we're going to be studying, and it's such a nice course to deal with. All right, follow me. All right, let's look at the first law of electrolysis, Faraday's first law of electrolysis. The first law states that, Faraday's first law, it states that what? The quantity or the mass of a substance deposited during electrolysis is directly proportional to the quantity of what? Electricity passing through it. So, mass of substance is directly proportional to what? Quantity of electricity. To remove this proportionality sign, we are going to have mass is equals to what? ZQ. Where Z is equals to is what? The electrochemical equivalence of the substance. Now Q is the quantity of electricity, and it is given by what? Current times time. Remember that Z, the unit for Z is gram per coulomb. All right. So with this now, quantity of electricity is measured in coulombs, current is in amperes, and time is measured in seconds. With this, we can say that mass is equals to what? Z. Quantity of electricity will replace it, IT. It's a very important formula that I want you to do. All right, let's look at an example. All right, the question says, suppose we pass a current of 2 amperes for 300 seconds through a solution where the electrochemical equivalence is 0.0039 grams per coulomb. What is the mass of substance deposited? Is that okay? Now, for us to solve this question, we have to write the formula M is equals to Z IT. Remember that the current has been given 2 amperes. This is I. Time is given T. And the electrochemical equivalent Z has been given. So we just fill in. So this is going to be what? 0.00039, which is the electrochemical equivalent, times the current, 2, times time, which is what? 300. Alright, press your calculator and give me the answer. We're going to have, if you press it, we'll have 0.1974 grams as the mass of substance deposited. If you find this interesting, first of all, subscribe or follow us depending on where you're watching. Alright, now first, like the video, subscribe, comment, share. Now let's move to the second law of electrolysis.